Welcome to the Bleeding Edge Report with Chris and Treg, where tech meets its match. Well, hi, my name is Treg. I'm half of the Bleeding Edge Report with Chris and Treg. I just wanted to do a quick introduction and give out a special thanks to our presenter this week, who we're going to be speaking with. His name is Dirk Wolter, and he is one of the top people in the entire world when it comes to 5G. We're very lucky to have him. He's an international consultant that started off with Ericsson back in the 90s, ended up with Cisco Systems, and now he's kind of a gun for hire and an international consultant that works with most, if not all, the top 5G providers in the world. And we're very lucky to have him. So this is going to be a two-part series. The first part, we're going to be talking about where kind of 5G came from and where it's at and what the promises were. And then the next part, which is going to be distributed this weekend, is going to talk about where it's going and what people can expect and pretty much how it could be disrupting the entire wireless industry over the next year or two. So we look forward to that. And without further ado, let's go ahead and just jump right into it. Oh, by the way, if you like what you hear, please like and subscribe. We appreciate it. Bye-bye.
Hey, hello, everybody, and welcome to the latest episode of the Bleeding Edge Report. I'm Chris with my co-pilot Treg, and we have a special guest today, Mr. Dirk Wolters from Singapore. Dirk, we've invited him to come and speak with us today about the 5G network and when will we deliver on all the 5G objectives that were so well marketed to us. So I hope you like this episode. We're excited about it. And I'm just going to go ahead and turn it over to Dirk, who is actually a distinguished consultant for about telecom as an expert for many clients around the world. And he is speaking to us this morning from Singapore. Dirk, thanks so much for joining our call today.
Thanks, Chuck and Chris, for having me.
So, Dirk, I'll kick it off with our opening statement. When will 5G deliver on all of its objectives of everything connected everywhere?
Yeah, that's a good question. So, 5G, we should say that most people don't remember that, but we are in year 4 of 5G already. So 5G is not as new as some people think. 5G started commercially, not in the lab and not in specifications, but in real networks already in 2019. The Koreans were the first to launch 5G commercially in April 2019, and the US followed shortly after that. So we are in year 4. The 5G adoption has been relatively fast. The transition to 5G was actually faster than the transition from 3G to 4G. And the reason why we're not really seeing much of a difference is that we are today still in most networks in the first phase of 5G.
What do you mean by that? Because from an end user standpoint,
not much
honestly,
change, right?
Yeah, I just see the little 5G on my phone, but it's about the same. So why are we in the first stage, and how many stages, and what's next?
Yeah. So let me go back a little bit to the previous phase we had. When we switched from 3G to 4G, we remember that this took a long time. It took a long time because handsets weren't available immediately. It took a long time, and when they came out, they were quite expensive. So mass adoption for 4G took a relatively long time because handsets were expensive and not available. And likewise, the upgrades of the telecom networks from 3G to 4G took also a very long time, and it was very CapEx intense. The reason is that from 3G to 4G was a massive disruption. So we moved from CDMA to OFDMA. So it's a fundamentally different radio protocol. And not much of the 3G network could be reused. Not much of the electronics. The base station had to be replaced. The core network had to be replaced. We moved from circuit switch technology for voice to packet and so on. So the move from 3G to 4G was a really big one, very disruptive. And I must say, as engineers, we love that, right? It's the latest and greatest. When I saw the 4G specs, I thought, wow, this is really good stuff. but the operators did not like it so much because they saw how much this would cost them. And that's also the reason why it took a long time.
Yeah.
So it's so disruptive that, you had to throw away much of the network gear and deploy a new network gear. That was expensive. So when discussions started on 5G, obviously all of us as industry players, we did not want to repeat that mistake. So we wanted to have something that is a little bit more smooth, and it's a little bit more incremental. And of course, we did not want to make this mistake of throwing away well-established 4G networks when we moved to 5G. So one of the key requirements that we had from the operators was the 4G technology out there, which in many cases was not fully amortized, should, as much as possibly, be reusable when we move to 5G.
I see.
And the reality today is that this is the case. So when you look at the radio protocols, in 5G, it's very similar to 4G. We still have OFDMA. We have wider carriers, but much of the modulation schemes, the OFDMA protocol, including the core network in the first phase of that we have now, is the same. So it's a very smooth transition to 5G. And that was the very purpose of that first phase. So the first phase, that's what we are in. And this is why you're saying, well, there's not much change. Yeah, right. There's not much change because we are not in a revolution. We are in an evolution of the 4G network. In many ways, what you call 5G today, and yes, you see a 5G logo on your phone, but it's more a 4G plus than really 5G. The real 5G is the second phase. And all these promises that we see, like connected cars and IoT, right, and virtual reality, augmented reality, all these new applications are enabled through that second phase of 5G. So we don't have that yet. So don't be disappointed with 5G. So what we see now is the first phase. Certain concessions had to be made to reuse 4G network equipment. And that's the reason why we just see a 4G plus today. Likewise, the phones, the phones that came out, the first set of phones were initially quite expensive, but today I think phone adoption is basically resolved as an issue. In 4G, we had this issue, right? It took a long time until 4G phones were available at a decent price. Today, most of the new phones that are coming out are 5G enabled.
Yes, that's right.
And that includes the low and mid-tier, right? So the new phones you can buy today for $100 US. The cheapest 5G phones are $100 US. So it's not the latest Galaxy or iPhone that you need to buy. So that's really great news. So yeah, to sum this up, we are in that first phase, which is not really the full promise of 5G. It's more a 4G plus, and that is enabled by what I would call transitionary technologies.
Right.
Which were purposely built into the specifications because we didn't want to make the same mistake. From 3G to 4G, it was too disruptive. Now, what are these key technologies? So they're multiple, but the two most important ones that I want to mention is NSA. This stands for, so not the NSA that some of the politicians think of now. No, it's the non-standalone.
Right.
That first phase that we are in, and most 90% of the commercial networks out there are today still NSA networks, non-standalone. Non-standalone means we do not have a full 5G network, but we have 5G radio base stations that are subtended to an existing 4G network. So we basically take an existing 4G network with its core network and its radio base stations, and we are adding 5G radio to it. So right. Non-standalone. And that, of course, has consequences, right? And these are the consequences that you mentioned. Well, if we still use a 4G core network and we still use part of the 4G radio, then, of course, there are certain limitations in terms of throughput and latency. Yeah. So
the next phase, based on what you said, is to now go back in and develop the network core in order to facilitate the additional capabilities that really are going to make 5G what it's been espoused and over marketed to do since earliest I can remember is 2014. So we're talking about this. When did 5G marketing kick off? And earliest I can remember is 2014. So almost 10 years. But that's the next phase. So my question is, when do you think that the build out of the network core is going to happen? And I say that in light of the economic headwinds that we're facing today.
Yeah. So that second phase has already started. So it's not all that bad. So the engineers know that 5G develops in multiple phases. We call that releases, or 3GPP is the specification that we use for cellular networks. The first release when we had 5G in 2019 was what we called release 15. Release 15 is the first 3GPP release which enabled 5G in commercial networks. Then we had release 16. Release 16 is what enabled standalone. Currently, we're on release 17 in the third phase already on the specification side. So obviously, the network deployments are somewhat slower than the specifications. Specifications are usually 1 year ahead at least. Right now, we're on release 17. Release 17, the third phase of the specifications came out last year. There was some delay because of COVID. So the engineers that do the specifications, they like to meet, and during COVID that wasn't possible. So we had to have virtual meetings. All of that delayed. So release 17 is the current specification, and we are going to move to release 18 probably in early 24. Release 18, by the way, is what we call 5G advanced. The first three phases, 15, 16, 17 is 5G. Release 18 is that we start with 5G advanced. So we can talk about this, what that brings. And then you might ask, when is 6G starting? So most people think release 20 probably in 28. We will see the 6G specification, and then commercial networks probably from 2030 onwards. Now,
so
Go ahead. I got a question here for Dirk. So some of our clients, let's just say, are in the software application side and some of the hardware applications. So while 5G has been sitting there for a long time, I think the first time I heard about it was around 2014, along with, I think it was Wi-Fi Max, or I forget what it was, that didn't go anywhere. But so if they're sitting there, let's say a typical CTO of one of our clients they're probably wondering, okay, I would like to get these applications more mobile for people to be able to take advantage of them. For example, some of our clients are maybe employee rewards based, or have to do with HR, and they're trying to take advantage of the mobile technology to develop their applications that can be used, so folks don't have to go to a computer or whatever. So my question is this: when can they really see the advantage of a true 5G? How far away are they from that? And for them to kind of look and say, okay, if we're looking at applications that want to take advantage of this speed, when is that eventually going to happen?
So some of these advantages show already today. So when we say that phase today is more 4G plus, the plus has a value in itself, right? It's not like 4G. There's a little improvement. Now, maybe it's worthwhile explaining what is the promise that 5G makes. So what are the things that should improve over 4G? And then we could ask the question, do we all need that? And for what do we need it?
Okay.
Now, fundamentally, we could say that 5G promises three major improvements. One is the speed. Of course, that is to be expected. With 5G, we will have our phones working a little faster. We could ask the question, do we need that? Maybe not, right? So most of the things we do on our smartphone, we can do with 4G, or with what we call LTE Advanced. So also with LTE Advanced, you can get more than 100 megabits per second on your phone, and that is sufficient for most of the things we do on a smartphone. There are other applications where it's insufficient. So speed is the first thing that we expect from 5G. The speed will go beyond gigabits per second. And with 5G, we are reaching speeds that are similar to fiber. So we could say that 5G enables fiber-like speeds. That has an application in itself. We see this in the US, for example, very successful deployments of fixed wireless access. Now, fixed wireless access has been around for many years, but it's just not economical. And in 3G and 4G, it was difficult because of capacity limitations. With 5G, we see a breakthrough in FWA, and in the US, especially in challenging geographies and rural suburban areas where there is no cable and no fiber, FWA, fixed wireless access through 5G, all the carriers offer that, Verizon, AT&T, T-Mobile, offers fiber-like speeds, and that's far more economical than pulling fibers into suburban or rural areas. So FWA, in a way, is the first successful use case for 5G, specifically in the US. We might not remember that because everyone like us engineers, when we talk about 5G, we prefer talking about the most sexy things on earth, like connected cars and virtual reality, augmented reality, IoT, and all that. But yeah, the first successful use case is fixed wireless access, not only technically, but also economically. So FWA is a good business case for the
and what would be a good example of an application for fixed wireless access?
So the first one is, of course, to provide connectivity. So I mean, to start with, what is different between fixed wireless access and a mobile phone? So on a mobile phone, typically, the average data consumption, it varies by geography, but if you take a global average, people consume about 15 gigabytes per month today. That's what people consume on a mobile phone, an iPhone or Galaxy phone today. Varies by region. There are some regions where we have like 30, 40 gig already. Now, fixed wireless access is different. So if you have a fixed line at home, let's say a fiber at home, or in the US, many people still have DOCSIS, cable-based systems, your consumption is far higher than that. On average, it's 10 to 20 times higher. Why is it higher? Because, first of all, and fixed wireless access, and fixed line today at home broadband is typically shared. So your entire family is using that. You may have the kids watching one movie and someone else is watching another one. You work on your computer. Some of your kids may do some 3D gaming, and all of that consumes bandwidth. Secondly, the type of applications we use on a fixed line are by definition more bandwidth hungry. So we have our Netflix on 4K, for example, right? So
that's right.
That leads to a situation where a fixed line typically consumes between 10 and 20 times more data than a mobile phone. That has been a challenge traditionally for many years, and in areas where there is no fixed. So traditionally, whenever you have fixed, you will use fixed. If you don't have fixed, mobile networks are often the only way to have internet connectivity. Now, in the US, it's a little easier, but think of markets that are geographically even more challenging. Think of
Indonesia.
Into Indonesia, or think of the Philippines, so many islands. And fixed wireless access connects the unconnected, those households that have no alternative. That was in the past. Now, today, with 4G, we had, unfortunately, the problem, and even more with 3G, that the amount of data that people would consume in their homes as a family was so massive that it would quickly exhaust the capacity that a 3G or 4G network could provide. And here comes the extra capacity that 5G delivers. It allows us, and not only to deliver the speed that people expect in their home, if you have multiple TV sets running in parallel on Netflix, well, it's nice to have a gigabit per second, and 5G allows that, but it also allows the capacity. So it can deliver hundreds of gigabytes to a household without exhausting the network.
So are they expecting that to be able to be delivered economically? Like it's affordable? Okay.
Yes, that's a good question. FWA in the past, even though technically possible, it was economically challenging. Now, why is it economically challenging? If you look at the tariffs that operators charge, FWA at first glance looks like an attractive model. For an FWA subscription, typically you pay a little more than a mobile subscription. So it could be $80, maybe $100 if you got a faster line, which is typically twice as much as what you pay for a mobile phone. Different countries, different tariffs.
Sure.
And in Germany, it's a little cheaper, but you could say that roughly a fixed line at home costs roughly twice as much as a mobile phone. So operators might say, well, that's great. We double our ARPU for one fixed wireless access subscriber. We get as much revenue as for two mobiles. That's at first glance.